All right, guys, good evening. Today we are going to continue with where we left off from yesterday. And we'll just recap some of what we have looked at from yesterday in regards to the mode. All right, so just going back through the definition for the mode, we said that the mode of a set of values is the value which occurs most frequently, all right? And that is pretty much straightforward. The one that occurs the most in a set of values, that is the mode. So we just pick out that one that occurs the most when we're dealing with the mode. Now, in some cases, and I should have made this correction with the typing. Can you just give me a chance to just correct this? All right, so here we have, in this set of values, we see that 4 occurs the most. So it means that the mode in this set of values will be 4. Now, sometimes we have all values occurring the same amount of times. And in that case, especially for example, to realize that each of these values occur one time. So none occur more than the other. So in this case, there's no mode existing, all right? Now this one here, we notice that we have 2 values that occurs the most. We have 3 and we have 6 that occurs the most. So both of them occur at the same frequency. So it means that we have 2 modes. And in this case, we would refer to this as a bimodal situation. Now we have unimode or unimodal when we have 1 mode. We have bimodal when we have 2 modes. And we have multimodals when we have more than 2 modes, all right? So this is just recapping what we did yesterday, guys. All right. We want to just refresh our minds about histogram, because in finding the mode, especially of a frequency distribution, the histogram is really important because it is the histogram that we use to determine the mode for a frequency distribution. And of course, as you would have known, the histogram is a diagram with a set of rectangular bars where the value for the data occurs on the x-axis and the frequency of the data occurs on the y-axis. So that really tells you that the histogram represents a frequency distribution. All right, so that diagram is what we're going to use to help us to find the mode. Now, there are 2 situations, or 2 scenarios when it comes down to the histogram. We have one scenario where we use the area to represent the frequency, and the other scenario, we use the height of the rectangle bars to represent the frequency. Now, in the case where we're using the area representing the frequency, what we notice is that the classes in that frequency distribution would not have the same width. And so the rectangles would not have the same width. So in that case, when the rectangle have different widths, we would use the area to represent the frequency. Now, we are not going to use that form of histogram when we are dealing with the mode. Now, the histogram that we want to use when we're dealing with the mode is one where all the rectangles have the same width. And in this case, where the rectangles have the same width, the height of the bars give you the frequency, or the height of the bar tells you the frequency of that distribution. All right, so we say that a histogram for a group distribution may be drawn by using the midpoint of the class interval as the center of the rectangle. And if you remember, with the frequency distribution, the midpoint of the class interval is simply, you're just adding the two limits of the class and then divide by 2. So you're adding the upper limits with the lower limits and then you divide by 2. That's how you find the class midpoint. All right, so once you're going to use a group distribution, you have to draw your histogram using the class midpoint to represent the rectangles, or the center of the rectangle. Now, if you notice here, we have a histogram here where all the widths of these rectangles are the same, and the height of the rectangles give it a frequency. And if you should calculate it, the midpoint of these rectangles would really represent the class midpoints. All right. Now, once you have drawn the histogram in this manner, all we need now is to either use the histogram to determine the mode. Now, the histogram is not the only way that we use to determine the mode. We can use what we call frequency polygon, right? Now, for the histogram, one of the things that we need to make a note of is that the base of the histogram, the side that it sits down on, the edges of the base, they are resting right at the boundary values. So in other words, the base is a flat side that the rectangle sits on. The edge is right to the end of the rectangle. So at the end of each rectangle, we have a boundary value, all right? And so once you join the histogram, you're expected to use the boundary values to form the edge of the rectangle base. So I hope you make a note of that. Frequency polygon. Now I mentioned that we can use a frequency polygon as well to determine the mode. So we have to learn how to draw a frequency polygon, which is not difficult. So we say the frequency polygon is a second way of representing a frequency distribution. And if you know what a polygon is, right, a polygon is really a many-sided figure. So when we refer to frequency polygon, we're really drawing a polygon from the histogram. Now, it is drawn by connecting the midpoint of the top of the rectangles in a histogram by a straight line shown as follows, all right? So here is what we do when we're drawing the frequency polygon. We find the midpoint at the top of each of the rectangles. Then we draw straight lines to connect these dots. And then the shape that you get from that will be your frequency polygon. Now we can move the rectangles, and then what remains is just a frequency polygon. All right, so that's how the polygon would look. So in essence, the polygon is really kind of a curve, so to speak. And so they also call it a frequency curve. All right. Now, this is another example showing you what a frequency polygon is like. So in a similar fashion, you find the midpoint at the top of each rectangle, connect the lines with those points, and then you get the frequency polygon. Now, in order to find the mode now of a frequency distribution, we may use either the histogram by itself, or we may use the frequency polygon. So to find the mode of a frequency distribution, we draw a histogram and hence a frequency curve, or otherwise a frequency polygon. All right, so the mode of the values of the variables correspond to the maximum point on the curve. So to find the mode, you look at the maximum point on the curve. So it means that wherever you find the highest peak on the curve, that's where the mode is corresponding to. And note that I say corresponding to because the mode is not at the peak, but the mode is correspond to the peak. Remember now, the mode is found on the x-axis, not at the peak. But where the peak lines up with the x-axis, then that peak corresponds to where the mode would be located. All right, so to find the so the mode, the second situation is that mode can be also obtained directly from the histogram. So if we're using the frequency polygon, we look for where the peak is, and then we find the value correspond to the peak. If we are using the histogram to find the mode, then we'll have to determine how to find where the mode line up by looking at the highest rectangle. But before we get to that, let us look at this diagram. This diagram here, we have a frequency curve or a frequency polygon, which is what you do, you just find the midpoint of each of these rectangles at the top and connect the dots with these lines. And then wherever you find the highest point on this curve, so the highest point on the curve would occur where this dotted line is. So that is the highest point on the curve. Now, remember I said that that's not where the mode is. So the mode is actually on the x-axis. So this high point corresponds to where the mode is on the x-axis. So what you do, you just draw a vertical line from that point. Wherever it meets the x-axis, you read the value of the mode there. All right, is that clear to everyone? Raise your hand if it is clear to you guys. All right.
Not clear to me.
Now, so we say the mode of the values of the variables correspond to the maximum point on the curve, and the maximum point is really the highest point on the curve. Now, this is the situation when we are using the histogram to determine the mode. Now, to use a histogram to determine the mode, we look for the highest rectangle. And this rectangle here would be the highest one, this one in the middle here. Now, what we need to do is to find a point that corresponds to where the mode is. And to find that point, what we do, we look at the rectangle to the left of the highest rectangle, we look at the rectangle to the right of the highest rectangle. And then now, from the corner where these rectangle rest on the side of the highest high rectangle, we draw diagonal lines to the top corners. So from the left-hand side, we draw a diagonal line from the lower left to the upper right.
That's where I didn't understand how. I understand that part now.
Right. And so from the corner of this left rectangle, we draw a diagonal line up to the corner of the top of the highest rectangle. And then we do the same now for the rectangle on the right. So from the corner of that rectangle, from the right, we draw a line right to the upper corner of the highest rectangle. Now, wherever these two lines intersect, you will now draw with your ruler a vertical line, and you can draw a vertical dotted line from all the way down, and wherever it cuts the x-axis, that's where you would read the value of the mode. Is that clear, guys? Raise your hand if you understand. All right. Good. Okay, good. All right, so that's how we really find the mode using the frequency distribution. Now, so first you would get a table with the classes and the frequency. So then now you would have to construct the histogram. So in either way, you have to construct the histogram. So even if you're going to use the frequency curve or the frequency polygon, you have to construct the histogram in order to construct those polygons or the curve. So you could just use the histogram directly by using the method that we just that I just explained to you. All right, guys. So that's how we work with the mode of a frequency distribution. Now, this is a frequency distribution, which is not a group distribution. Now, how do we know that this is not a group distribution? Now, in the left column, we notice that we have a list of numbers starting from the top in ascending order all the way to the bottom. Now, we know that group distribution would have classes, and classes would have upper limits and lower limits. So this is just an ordinary frequency distribution. However, you still can construct a histogram using this kind of distribution. Now, all you have to do is draw some rectangles having the same width. So you would not be able to determine the width of the rectangle by a class because you don't have a class here. But what you would do, you would make a decision you would decide on a width of your choice, a reasonable width. And then what you do, all the bars that you're going to construct, you give them the same width. Now, remember now, these values in the left column going to be at the center of these rectangles. And these values going to also be on the x-axis. So on the x-axis, you would have your scale that represents your number from 157 up to 167. So those would go along the x-axis. And at the point where you have these values, you would just put the center of the rectangle above these values on the x-axis. And then now the height of the rectangle, so you would just use the frequency, because on the y-axis, you're going to have you scale with the frequency. So in order to determine the height of a rectangle, for each of these values, you look at the frequency that corresponds with the values, and then you draw your rectangle up to that height on the frequency axis. So this is what it would look like, right? So if we go back to the table, we notice that 157 would correspond to a frequency of 20. And back to the diagram now. So this rectangle would go all the way up to 20. So the height of that rectangle would be 20. Notice on the y-axis, the height of this rectangle is at 20. Now, the number 157 is at the center of the rectangle, right? And so that's how you would draw this histogram. So you draw rectangles all of the same width. So all of them must have the same width, but you position them so that they're at the center of each of the values on the x-axis. So this is 157, 158, 159, 160, 161, 162, go all the way up to 167. And so if we go back to the table, so 158 would correspond to 36. If we go back to the diagram now, we know that the second rectangle here would be 158. Now, this height must correspond to 36. So if you move across to your frequency axis, you should, if you line up this with your ruler, you should get 36 on the frequency axis. All right. And so you would do that for all of the values. So here you have 159 with 44. So 44 would be the height of the third rectangle. Then you have 160 with 46. And if you notice that 46 would be the highest frequency, and so that would give you the highest bar. So the highest bar would correspond to 46 in terms of the frequency. All right, so having construct all of these vertical rectangles, then you would have used the method as I mentioned before. You look to the left of the highest rectangle, and you look to the right, and then now you draw your diagonal line from the corner of those rectangles next to the highest rectangle. So you draw from corner to corner your diagonal lines, and then wherever the two diagonal lines intersect, you draw a vertical line down to meet the x-axis, and whatever value you read from the x-axis, that gives you your mode. So the mode here will be 159.7. Now, with your graph paper, you should be able to have a more accurate reading because you'll be able to count all those tiny boxes to tell you exactly what the value is. Now, I'm going to ask that you guys get some graph paper for next class. So invest in a pack of graph paper. You don't have to buy a big pack. You have graph papers that have like 50 papers in it. So you can invest in a pack for next class. Is that clear to everyone? Is that clear, guys? Raise your hand. All right, guys. So please come with graph paper.
We would have graph paper for next class.
Yes, because I'm going to ask you guys, I may have you guys do some activities in relation to graph and the frequency distributions, all right? So I want you to get some practice on this because not everybody is really clear as to how to really construct like the histogram or
Sorry, I'm breaking up.
I'm just saying that you need to carry graph paper to the next session, all right? Because you're going to do some practice. All right. Now, what we have here, what we call measure of dispersion. Now, measure of dispersion is some means of measuring some values relating to stats. And you're not going to get deep into this because you won't be tested on it. So all that we need to know in terms of the measure of dispersion is the different types that we have. So we have three measures of dispersion. We have the range. And in order to calculate the range, you subtract the smallest value from the largest value. So when you have a distribution in the left column, you look at the smallest value and you look at the highest value. And in order to calculate the range, you subtract the smallest value from the largest value, and that gives you the range. Now, the next thing that we know is quartile deviation. Now, you would have met this when we were doing median, because this was something that I had actually mentioned that you can calculate by knowing the upper quartile and the lower quartile. The lower quartile is quartile 1, and the upper quartile is quartile 3. So you read the values for these of your ogive in your cumulative frequency curve. So you read the values for these, take away the lower one from the upper one, and then you times it by a half. And so that's how we calculate our quartile deviation, also known as semi-interquartile range. Now we have what we call a standard deviation. Now, as I mentioned before, we won't be doing anything with the standard deviation. Once upon a time, it was on the syllabus, but it's no longer there. So you're not required to do standard.
Sir, could you go back over the range of how you calculate that, please?
All right, so let me just jump back to this table. So here we have a set of values, your heights. And if you're to calculate the range, we look for the largest value, which is 167. We look for the smallest one. So we just subtract the smallest one from the largest one, and that gives you a range. So the range here would actually be equal to 167 minus 157. All right, and whatever you get from that value, that's supposed to give you what, 10?
Yes, sir.
And so that would give you your range. So the range would be 10. Is that clear?
Yes, sir.
All right. All right, so you would have learned then how to calculate the range, how to calculate the quartile deviation, but you would not be doing the standard deviation. All right. And so this would be where we would wrap up with our statistical averages. All right. Now we can make some comparisons with the averages just to see which of them works well in what situation. So if we look at the mean, we can look at some advantages of the mean. And first advantage is that it is the best known average. The mean is the best known average. And you remember how to calculate the mean. You sum up all the values and you divide by the number of values or the amount of values. All right, so it is the best known mean. It can be calculated exactly, right? Now with the median and the mode, you don't really have an exact calculation for those. So the median is just dependent on which number fall in the middle. The mode is dependent on the one that occurs the most. But for the mean, you would calculate an exact value. All right, so that's one of the advantage. It makes use of all the data. So all the data that you have, when you collect them, to calculate the mean, you would have to use all of the data. All right, so the mean makes use of all the data. The median only pick out the middle one. The mode only pick out the one that occurs the most. So those don't really use all the data in terms of calculating. Now so it can be used in further statistical work. Now further statistical work would mean a little bit more advanced than what we're doing now. So if you're going to the CAPE level, you will learn some more things in statistics that you would not really be exposed to here. All right. Now, some disadvantages. It is greatly affected by extreme values. Now, what do we mean by that? If we say we have some values and we're trying to find the mean. So let's say we have 2, 3,